We are already known with our next speaker, Mr. Niladri Roy. He has already delivered a speech yesterday only. But thank you, Niladri da, for again having giving us a chance to hear from you. So it's a formality again to read out your bio. So, Mr. Niladri Roy has been associated with Tata Consultancy Services for over 19 years with a total of 25 plus years of diversifying IT experience in planning, designing, implementing, and managing end-to-end IT portfolios from solution architecting, program management, service delivery to product development across the globe in multiple domains like retail, telecom, BFSI, manufacturing, government, etc. He has a lot of global certifications, which are like mainly included as Azure AI Engineer, AI 102, Azure and AWS Architect in public cloud, Prince 2, project management, ITIL, IT service management, TOGAF, enterprise architecture framework. His educational qualification is mainly he has done MCA and then he has completed his MBA in international business. He has a lot of contributions towards our society, mainly his TCA CSR is ACM Kolkata chapter secretary, IIT Kolkata chapter treasurer, CSI Kolkata chapter managing committee member, etc. So we are again fortunate enough to have Niladrida with us. Niladrida, over to you.
Thank you. Thanks for the introductions. I hope yesterday sessions maybe some useful to you people. So if anybody having the query on the yesterday sessions, then anybody can raise the hand. Else, I will start the uh, more sessions. So I, for the interest of the bandwidth, I basically disable my camera. Okay. So any query?
Participants, if you're having any query, you can raise your hand. We'll unmute yourself.
If no, then
Yes,
I
I
think
think yes, you
I'm
can start.
sharing my screen.
Sure.
I'm sharing my screen. Let me know whether it is visible or not. Is it
Yes,
visible?
yes, it's visible.
Okay. So good afternoon, everybody. So few slides already, we covered yesterday. I'm just keeping those slides. So I hope this is a system architecture, because from the DevOps point of view, CI/CD pipeline, that you need to understand that system architecture as well as the applications, because it is a combination of the development and the operation. Means IT operations mean mainly in the infrastructure systems side. That means that your development and system both need to be understood. So cloud computing, I'm moving these things, the basic of the cloud computing, like a shared responsibility model already done. So this is also yesterday I explained like a evaluation of the application architecture. So those the web application sample web application architecture I've already provided. Web application is already there. So now I basically want to share something about the containerizations. Because because this is the containerization nowadays from the DevOps point of view, everything we are basically moving to the latest it is like a microservice and microservice, and we basically create the container. So before start the CI/CD pipeline, I basically want to give you the some of the very basic idea about the containerizations. I don't know the how many people are about the detail knowledge about the containerization, but it is very useful because every organizations nowadays refactoring their entire deployment, development in a containerizations, because and that they moving to the APIfications mean the microservice. So and that Kubernetes is a de facto for the deployment point of view. So in a DevOps point of view, this is the you can say the dominance area that we need to be understood. So containerization point of view. So assuming that virtualizations concept, everybody aware of the things, but the in order to virtualizations also, so many IT operation overhead is there. Like suppose in a virtualizations environment, what happen? In a you have a you can have a high capacity server. On top of that, we need to basically install the hypervisor. So hypervisor means which is the software which is responsible for slicing the hardware with the logical unit of the hardware. Like if I have a 40 core means one hypervisor like a VMware vSphere, then it is basically create the 40 component of the vCPU. We used to say the virtual CPU. For the memory, that is also, so for that reasons they can, if any operating system required any underlying hardware resources, the hypervisor basically bring those the logical unit as a pretend as a physical unit. So hypervisor give the abstraction to the end user, like you can create a in a 40 core server 20 GB hard disks or the 20 GB hard disks and the 256 GB RAM. Then you can create the 2 core CPU and the 16 GB RAM VM. So that can be done. So same thing, the concept on top of that, what happened, like we basically face uh, we develop something in our development environment. The challenge was there, like we developing something in our development environment. When we deploy that code in a production, then we have faced, okay, it is not running properly. Why it is not running properly? Because maybe then a production that is a huge AIX server or HPUX server, or maybe the mainframe, not mainframe, that is a big servers which is having running on the VMware or that natively. But in our development environment, we used to do everything in a Windows, merely in a Linux. So some of the hardware dependency is there. Hardware dependency means, suppose if you are having the system with a bricks-based architecture like a AIX, but the in your development this is an Intel-based architecture. So that was sometimes we are facing some lot of hardware-related dependent issue. So the from application point of view, so Java is a very popular. Why? Because Java is a platform independent. Like a the in and in this regard, first they thought of that, okay, we can do something like a platform independent. So whatever we do in a our development box, now if it is running properly in our development box, that should be running in a productions environment. So what they do, they basically Docker or that time the container D, Google Docker is another company, and Google having the Kubernetes, they create a containerizations engine. Containerization engine means that is the container engine which is run on top of the operating system. And on top of that, if we deploy any applications like as a container, if we deploy, then that application not able to understand what is the underlying hardware. So suppose that means like a Java, what is done, that we have a JVM. JVM what do that, if you install the JVM 17 in a Windows machine and JVM 17 in the Linux machine, if you run that code on the Windows machine, that will be the same code can be run in a Windows machine. So JVM basically framework and is a abstraction layer which is create a platform independent. Same thing for the overall application point of view. Like suppose I have applications I am basically developing in a Spring Boot, which is running in a Windows. If after that, if I deploy, if I create a one container, and if it's running in my laptop, that same container will won't be having any problem in a production environment or any other environment. Like a just same think about the like a Java code, like a one app one. Uh, App one, app A, app B, app C, all are the things that instead of the entire application, it will be like a one jar file. And Docker thinks about the Docker is a your JVM. So underline whatever the operating system, that is, I mean, that is not any problem. So for that reasons, that all applications, suppose if I am having a one host in a Windows and another host in Linux, so we can pick and drop, then it will work properly. So it is like a, that's why. And second thing is that it is a very lightweight, means very small footprint. Like a in our operating system, you know that we need a GUI, like a, in order to manage the operating system. They are having multiple services, but the, for Docker, they need basic system tools and runtime in order to run specific application. Like a, suppose one Docker container in a Spring Boot is one Docker container is a, maybe that is from the Redis, one Docker container for the Postgres. So only for Postgres, how many component is required, that will run on the top of that. You think about like a one VM, it will take the 1 GB of the storage, or the near about 30-40% of the memory in order to run the operating system itself. But the Docker can be run with the 1/10 of the resources. So that is the beauty of the Docker. And if required the more compute, then we can create the multiple Docker, like a, we can scale. Normally we can say that is a horizontal scaling, like a one suppose I one Apache Docker basically serving the 1,000 of the concurrent request. Now that your workload is increases, so it's maybe 3,000, then we can create the three, we can spawn the three Docker container. So from the same thing, that type of application load balancing that is given by the containerization. That's why the containerization is a hotcake of this in current environment. So this is the basics of the containerizations. So now come to the Kubernetes. Kubernetes is not a container. Kubernetes is just a, you can say that orchestrator. Orchestrator means, suppose I have 1,000 of the container is running, and that need to be orchestrated. Like a our we need to configure such a way, like a MySQL container can connect with the I mean, one of the PHP container can connect the MySQL container, and another maybe our like a Java container that also need to be connected to the MySQL or another MySQL container. So these type of so many mesh environment is there. For that reasons, that all entire thing need to be orchestrated, need to be in a scale. Scale means we having a problem, advantage of the auto scaling, means automatically if the workload is increased, then automatically it will create the it will basically create a one container, then again one container. Like I have a one Apache server load. If we can configure such a way that if it's increase the load, then automatically it will create the two container, then three container, four container. Again the load will be the less, then automatically it will down. This type of auto scaling things, the features is coming in the that will be the completely orchestrated by the Kubernetes, because Docker engine only responsible for the up and down the down the container. But any of the orchestrator like a Kubernetes, prior to that, Docker having Docker company, they are having one product, Docker Swarm. Earlier we used to work in the Docker Swarm up to 2017-18, and then 18 or 19 onwards the Kubernetes come to the market, and it is basically kill everything. So before that, the Meson, so many orchestration is there. Like you can say there is a cluster thing, how the cluster management is happening. So second thing is that auto scaling, then the resilience and self-healing. That means suppose your container is down, automatically it will up. To think about your application developer, suppose in one application down, it is very difficult to up these things. that is a big pain for the any application development. Those kind of resilience and self-healing, it is a default features for the Kubernetes point of view. Like a persistent storage, like a some, it is a very disadvantage that since you understood, like a suppose one container up and then again is down, again up, again down. But the since it is a container mainly application footprint, what would be the if I want to configure one database container like a MySQL, Postgres, Azure SQL, what I mean not Azure SQL, from MS SQL or any database. So database, all data should be the static. That is, suppose data, if database is down, because what happened, the container thing is completely dynamic. Means if the container go out, I mean container is basically down, then automatically you lost the all the things. You think about the RAM, but they need a one persistent storage. Those kind of configure can be done in a Kubernetes. Load balancing, DevSecOps support, everything is can be done. Lifecycle management, automatic deployment. That is, for that reasons Kubernetes is a huge, and the all Kubernetes is open source, and every organization is basically taking care of the Kubernetes. Now think about, Kubernetes is being developed 15 or 10, 20 years back. Google only released this Kubernetes technology 2015, 16, something like that. And after that, everybody basically adapting these things. So all your Google, that entire Google is basically run on the Kubernetes. Maybe that thousand, not I mean million containers running in a Google environment. So this is the Kubernetes. So type of deployment. Normally, what happen? So this is the beauty of the Kubernetes. Like a, suppose I am basically developing version one. It's running in the productions, but the sometime I basically need to be understood. Okay, I have a new release I am giving with the features, and that some of the incremental development and patch. Then after that what happened, that need to be checked that whether it is working properly. Like a, say suppose I am an e-commerce portal, I giving an example. I am basically introduce a new features, like a, you can previously you cannot pay with the e-commerce portal. Now I am basically implement the pay, like a payment gateway. So in the same development, only the payment gateway model you basically implement in the version 2. So that is that is need to be tested in a sometime in a real environment. So for that type of environment, we used to say that the type of deployment, that is a blue-green deployment, canary release, the A/B testing, like a 50% container, a 70% container will run the version one, and 30% run will the version two. After that, what happened, that if it is something is working properly, and then we can move from the staging to the production. This kind of deployment we can do. So since it is a huge I mean all the deployment like with the containerizations, and it is targeting in the deploy in a cloud. So this concept is concept is coming, the cloud native design. What is mean by cloud native design? Cloud native design means it is a, we need to develop our application such a way that can be very much comfortable with the cloud native. So like a, suppose what happened nowadays, everybody know the mean stack, man stack, so many stack is there. My full stack means one is the component, one of the maybe your UI is running in a Apache, your React or Angular will run in a Node, and that your database will run. So everybody can call with everybody, and then when all will go with the API gateway. So in an environment, cloud native, that is the one API gateway that can be done. Like a, suppose you can see that is a ordering microservice, catalog microservice, identity microservice, basket microservice. That's how all the separate microservice. Like a basket, they have it backed by the Redis cache. ordering the relational database, maybe MySQL, PHP, MySQL or Postgres is there. So marketing like a NoSQL, like a Cosmos DB and other is there. So this kind of each and every microservice have been different, and all the front end applications like a mobile app or the web app, every day will connect to the API gateway. So this is the called the cloud native design. So why cloud native design? I will come the later in the details way, because we initially it is very difficult to manage the all the infrastructure, all the system. Now customer, yesterday I showcased something like a app service or the AKS service, Azure Kubernetes service. Those are the managed service. Though I mean, customer no need to bother about the underlying administrative administrative things. They can be done. So that should be ready. So this is called the cloud native design. So cloud native, I'm giving the two example here, like what happened. Though I'm coming the later as itself, like this is the one of the example of the Azure, how basically one cloud native implementation happened. Suppose we have a client application, like in your machine, in your system, you need some of the service. Like I'm giving, suppose you develop a one business applications where that some of the exchange information, like a exchange information is required. Exchange means currency exchange in your system, like a suppose someone in your education system, some of the student maybe overseas, they need to pay something in a dollar, euro, but that conversion is required time to time basis. So you think of, instead of the developing this the currency things in order to maintain internally, you can leverage the cloud-based service. So what happened? Like you are the, it is like a cloud, your client application that you will develop in your things. Like then some of the services is there in a managed common service space in a cloud. So what happened? The cloud application connect to that. Then like, you can see the Azure Kubernetes service. They used to have their own component, some of the component front end utility, and then this is the way, like all the you can say this is the implementations. Now for the AKS Kubernetes service, AKS means Azure Kubernetes service. They're having the Kubernetes cluster, and the cluster also all the this is the boxes, means all the pod that can be communicate with the Azure Activity. Then the DevOps Azure pipeline, we can deploy the all this code and the container, and then it will all the container like a your cloud service can run over here. So this is the detail. I mean, this require the more. You can say that more knowledge about the Kubernetes, but this is the way we used to implement our services. Like we used to have the hub and spoke, like a cloud having hub, and all the client applications they will connect to the cloud through the Azure load balancer, something like that. So same thing from the AWS perspective, same we can deploy. I'm not going in far here. And for since this is the important, I believe if anybody nowadays, that Apache, maybe that one of the open source giant is Apache. Same like a Linux Foundation also. This is another giant for the open source development. Majority of the people now is moving to the open source, not go for the proprietary. For these things, some of the organizations taking as a guardian, as a guardian kind of things, the governing the things. And there is a from Linux Foundation, there is a one of the initiative is the CNCF, Cloud Native Computing Foundations. This the CNCF is a responsible. It is established in 2015 for the mainly depends upon the advanced container technology. Huh?
Hello.
Hello.
That probably there is a query from one of the
Okay.
participants,
Yeah, yeah, yeah.
Jinatul Islam.
Hmm. Hello.
So you're talking about
Sir, your voice is breaking.
Nginx server also. So does Kubernetes do the same kinds of thing, load balancing or something? Hello?
Can you come in again?
So you got my question?
No. Sorry,
No.
please. Can you comment again?
Sir, your voice is breaking. So
Suppose regarding Kubernetes, you are saying that suppose in Nginx server is there, Apache Nginx.
Yes.
So we can do load balancing. Suppose we can install the application in different servers, then we can balance the load. So does Kubernetes perform the same thing? Load
No.
balancing?
Load balancing, it is responsible for the Nginx, but Nginx need to be deployed na. So what happen in your
Yes.
environment, you one of the VM you install, or one of the desktop or laptop you install the Nginx, am I right? And another laptop
Yes,
you
yes.
think about that, install the Apache server, or something, I mean your Java server or the .NET server. So what happened that
Okay.
Nginx basically redirect the traffic from the one to another. So for the Kubernetes is like a underlying infrastructure. Okay, so instead of
Okay.
the install your laptop or desktop, you can create a one Nginx container, and that container
Okay.
need to be deployed in a either in a, if it is a standalone. Normally what happened in our environment, we in a
Hmm.
laptop we install the Docker. On top of that we deploy the Nginx container. Now think about that, you need a 10 Nginx container, like a operating system load balancing point of view. Okay, so suppose high
Okay.
availability, like a one suppose you have a one Nginx one Nginx box, but if that Nginx
Okay.
box is goes down, what happen?
Okay.
It cannot be done, that it cannot load balance, am I right?
Yes, 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 yes.
Yes, so you need a two Nginx, but that two Nginx need to be in a cluster mode, so that once goes
Yes.
down, another can up. Or maybe suppose if Nginx box is go, your laptop goes down, then entire thing happen. But then in a container, what happen? Like you can create a Nginx container. If the container goes down, automatically in so self auto healing is features is there. It will basically Kubernetes check that whether the service
Hmm.
up or not, up or not, up or not, up or not is down. Then again, it is a trigger. You can up the container. Some of the
That
background
means
voice is
Kubernetes will be helping in automatic scaling, right? Like suppose
yes,
whenever
yes.
there are.
Hmm. More than
Okay.
suppose more than multiple more than one like a, Nginx on not only load balancing, it is basically doing the web server kind of thing na, and the CDN.
Yes, yes,
So if you require
yes.
the, you need a multiple Nginx, then you can configure, but the in the underlying that is cannot be done in the Nginx, because that is depends upon the operating system level configuration, am I right? That
Yes, yes,
operating
yes,
system
yes.
level configuration, that will be the Kubernetes will be the responsible step. So like you can think the
Oh,
what is the orchestrator do? You have a 10 violin player, two tabla. So orchestrator who basically orchestrate, okay, when you start, when you stop, when it the based on the songs. The orchestrator is the
okay.
responsible in Kubernetes, which container will up, which container will do, how many container need to be up, how many container need to be down. Those kind of scheduling, management, everything responsible from the Kubernetes point of view.
Okay,
Okay.
sir. Thank you, sir.
Okay.
Got it.
So
Yes, sir.
now you got it now. So here you can
Yes, sir.
see that is a in a CNCF what happened, more than huge number of software is there. Like you are the developer, you can develop something from the container related application, like a monitoring software you basically develop, and then you can approach to the CNCF. They will check that whether your application is fine, then they will vet it and they will publish. Then publish, there is a three step is there. One is the you can say that incubations. Then something like a top level is a graduate means this is a proven tested with the multiple way. So these are the, you can see these are the graduated, just go with the type CNCF. You can find, I mean, world all the best, all type of software is available, open source software is available, but the here is a top software it is there. and this is a more than 450 members are there. For members means the company, like IBM is a company, like a Cisco is a company, all are the members. Okay, and they develop something like a
Okay.
Kubernetes developed by Google. Okay, Envoy from the service proxy, Argos like a continuous integration and deployment. This is now is a very hot cake. Hem, we used to deploy the container through Hem. Istio is a basically service mesh. Jigger is for the observability. Observability means login, monitoring, and the coding. Those kind of thing. Cubase is a small footprint edge. If you want to run the Kubernetes in the edge computing, like in a Raspberry Pi, you can use the Cubase kind of thing. Okay, so those kind of all other is a graduated. It's not like that. The other project also there. Observability, like a suppose Prometheus is using for the monitoring purpose. Like a harbor for the container registry, Fluentd because I'm using those things. Fluentd for the log management, log any log, whatever the container log, server log, application log, the container Fluentd is responsible for the catching that things. Cryo is a container runtime like a Docker. The Docker, like Cryo is another one. Okay. So those kind of and other very more than 100 software is there, but these all the graduated software means it's a well tested like a Kubernetes, Helm, Argos, all the Flux, all the other things. So someone who basically willing to deploy working in the Kubernetes environment or in Docker containers environment, these are kind of software you need to work with. Okay, so those are the maybe several software is there. I will come later, but this is the top software, you can say top open source software. So this is from the containerization point of view. Any further question from the container point of view that I can accept? Then I'll move it to the DevOps kind, DevOps area. Any question? One hand is there, still there. Zinatul Islam. I think no one there. So I'm going for the next sessions, like a DevOps. So DevOps is a not a technology. DevOps is a basically culture, or you can see. So many of the people may think about that. What is DevOps? DevOps may be technology like a cloud. Cloud also not technology. And DevOps also not a cloud. Cloud having the group of technology, and DevOps has a culture, and whatever the tools and technology using, that is we say the DevOps technology. So what happened? 2001, the Agile manifesto is. If anybody having idea about the Agile development, is it the Agile is part of your curriculum, or like a software development? Normally, we know that waterfall model. Is Agile in your, I don't know. Okay, no response. So nowadays, we are not go for the, waterfall model. Waterfall model means what? We first do the project requirement analysis, the requirement. After requirement analysis, we do the design. After design, we do the build and development. After build and development, we do the testing. After testing, we will do the production deployment, and after that, followed by the operational support. These are the waterfall model. But then Agile, then that means what? I'm giving the again example for the e-commerce platform. What happened in the earlier days? Suppose the one company like a Manchana, they basically want that I will sell my sweets through the e-commerce platform. Okay, so they want to build a one e-commerce. So what happened? They basically first bring the all the architect and project manager. that architect will design that entire thing, like a technology, data, information process. All that architect is responsible for designing. After that, developer will come to the picture. They will, and that system guys, IT operations guys, they basically build the environment. Developer do the development, and then the testing team come the picture. After that, the e-commerce thing, entire e-commerce platform will happen, which is including the basket, catalog, online payment, everything is come to the picture, supply chain management, everything. So think that way. Then means after maybe 6 months or 9 months, when the actual go live happen, then it is find that okay, it is not working properly. For that reasons, meanwhile, what happened that developers say that my code is working properly in my laptop or desktop, but it is in your environment, testing environment, it is not working. Not problem, it is not my problem, it is a maybe tester problem or operations problem. So this kind of happening. So instead of that, like a this concept is coming, the agile means very dynamic. So instead of that entire thing, they break down in the multiple model, and the all the features break down, and that whatever the minimum features, which is called the MVP, minimum viable product. So they basically create a MVP or POC and start with that. Okay, start with the very basic. You no need to go for the payment gateway. Only you just listing and check that whether it is I just initially I just want to see the feedback, that which product you want. So and in nearest store you can get those things, you no need to pay anything. So this is the minimum features that need to be deployed, and once is maybe the TCS CTS got the contract from the Bancharam, then we'll deploy. And then so parallelly what happened that all the payment gateway, everything also going to development. So all the parallel activity happened, and then this is the from the delivery point of view. Second thing is that team point of view, what happened. The earlier they said that operation guy is separate and the development guy is separate. Okay, like a TCS do the development, Infosys do the testing, and Accenture do the infrastructure. Instead of that, say that okay, all the all these type of your features, like a catalog system done by the TCS, and TCS you need to bring your developer, you need to bring your tester, and you need to bring your infrastructure guys. So now it's happened that for the any catalog management, any problem will come, TCS will be responsible. Earlier what happened, TCS will say that is the Infosys problem, Infosys say it is the Accenture problem, Accenture is the TCS problem. This kind of mess will happen. Now it is that like a philosophy is like development team and the operation team come in the same team, and you need to deliver. So concept is like that. Shift the scope and accountability. You build it, you run it. Clear? So this is the this is the philosophy of the DevOps, and for that reasons, every organization's moving to the DevOps and environment, DevOps culture. So in the DevOps, like if you see the same thing for the waterfall model, is it same? Like first we need to develop, then the plan, then you need to develop, then we need to integrations, continuous integration, do deployment, do testing, do operate, and do monitor and feedback. So but here we say the continuous integrations means what? Like suppose I suppose I have a 200 developer. So initially what happened, that all the developer basically write a code, they shift the FTP or something like a shared drive, then one of the guys there, they basically integrate all the code, then it is deployed to the various Java server and .NET server, whatever. After that, any build fail happen, then it will back to the developer. So that's maybe environment setting is not there, something is a variable is not passing, something like that. You just build your and give that to the, you do the testing your things, and after that you can give the UAT environment or QA environment. But the thing is that it is that to and flow has happened, and that part now we through software we can do these things. and initially like each and everything, not it's a completely like a GitHub is a ACM de facto. Git is a technology from the service source code management for development perspective. After that, so many other tools are there that can be integrated the things, and after that it will deploy. So that is happening in the continuously, and then automatically it continuous testing there. So I can give you one initially one of the application development we used to have that 2000 3000 people. Now it is sync with the 200 300 people. 10% 20% strength is it is reductions happen. So all are the doing in an automated way. Now think about the bank. What happened? Each and everywhere that our economy is earlier 60 70 80, so many people required in a bank. Okay, because banking system is basically growing like anything, and all the required the people. After that, the IT is come. Now we think that entire thing is done by majority is a banking through IT. So think if the no IT is there, now SBI, I believe SBI need the more than 1 crore of the banking staff in order to run this same show. Okay. So think about that in IT also. Nowadays, all the semi and the semi skill, unskilled things automatically done by the automation through automation or AI. So this is the big thing. So this is the circle. So whatever I said that I'm giving a small yesterday I show these things, and I just elaborate here itself. So what happened, developer basically they having VS code or Eclipse, they develop something, then they basically commit the code in a Git, and after that they basically build the environment like a Java for the Java build, Microsoft for the Microsoft build, they build the repository for the SQL, they basically SQL files, they will keep the files in a single repository. So you can say that is a Nexus is a very good tool, and JFrog Artifactory is a very good tool for the artifact save the all the artifacts, because all the source code they supposed to should have their version control of the things. But this is the automatically like it is a scheduling something. The Jenkins is a de facto here. Though right nowadays Jenkins we are not using, but the 10 years back we are using the Jenkins. So Jenkins that time that is a hot product. Still it is a hot product, many of the, but the now it is going to cloud, all the DevOps part, the cloud services we are leveraging. I am giving the example for the Azure DevOps, but the earlier time we used to build the things Jenkins. That means suppose 200 source code, 200 developer give the source code, you no need a person to build the things with the Java through Maven build or the Microsoft build. So automatically Jenkins having the script, and when they push the when the developer push the code in a Git, automatically trigger that a new code is coming, and automatically Jenkins pull that code, and that then build the artifacts and save in a Nexus repository. Then that Nexus repository, then again Jenkins, once the Nexus repository then jar file is created in any Tomcat or the JBoss server, Jenkins is basically find the new things and automatically again trigger and build binary will be the deploy. So deploy in a any application server. For container also, that your what happened, same deployment is happen in a our service based implementations, like a in our laptop or desktop or server we have a Tomcat server, we can deploy this way. But the container we need to create the container image, like that will be the container image is to say in a Docker Hub or the Nexus, and after that that can be deployed either in a standalone mode in a container runtime or the orchestrator way Kubernetes. So that is can be deploy also Jenkins. So deployment things, build and deployment, that is Jenkins used to do. So this is the, you can say, the overall DevOps things. And on top of that, like yesterday said that we need to do the various security testing. Like if it is static, there is a stash hash, and it's a dynamic, is a dashed. So this is the, and for the container, like we used to do the container scanning image. So this is the this is a very good reference for the all the tools. I find it seems like a it's a basically predictable. I like this thing, then for that reasons I share it here itself. Maybe it, like you can see, though it's a notable, all the other notable product is mentioned. It's not like all. It's a important. Like suppose source codes management. GI means GitLab, GitHub, Subversions, ISPV, Artifactory, Nexus, all are the you can say source code management. For database automation, that the dictatorial DB Maestro, all are there. Continuous integration, Jenkins, code VSTS, TeamCity, Stable CIs, all are there. Though is a very old, latest. It is not a latest one, but this is the one. Then the testing maybe hard that the selenium J unit, all the J meter, all the testing things for the configurations like a shape, puppet, ansible, terraform are there. For the deployment, like a definitely go cd, argo cd. Now is the it is a old one, argo cd octopus deployment, octopus cd is the old one. Now the argo cd will come in here. If it is updated, not a is a old version, that's why. Container like a Docker, Kubernetes, all the Mesos, all the GKPK, and the cloud means AWS, Azure, and then the AI ops like a Splunk, and then they are. So this is the analytics monitoring. So in our DevOps, monitoring is a very important thing. Security is an important thing. Monitoring is we have a and the collaboration means management like a Jira, Slack, all are the collaboration tool. Nagios is for monitoring, JetBricks, Nagios, and the applicable there Dynatrace, Neural, this was the thing. So these are the area. So nowadays what happens like a GitHub, you everybody know the GitHub having the GitHub action end-to-end DevOps features they used to get. Same thing, the GitLab is another organizations, they used to give the end-to-end things. They can do the planning, create, verify, content integration, packaging, security release, all are the they used to do from the and Jira is a leader for the for the agile delivery management tool, project management tool. So this is the board dashboard, that full Jira dashboard where the Scrum and the Kanban board. This is the Kanban board, like a to do, in progress, all this Kanban, and that all the plan mean backlog, sprint wise deployment, all these things and done can be done in the Jira. So Jira and the Azure DevOps also there. So so this is the, you can say, the DevOps tools, just a glimpse of the DevOps tool. So any question? If you have any question, then you can ask. Else I will move to the Azure DevOps part. This is one of the cloud-based implementation of the Azure DevOps.
Participants, you can raise your question and raise hand so that we can make you a presenter. Chinatul sir, do you have any query?
No, sir. Actually, the hand is
Okay.
raised earlier. I have understood. Good content. But hand
Okay,
is
sir.
no, it should not be raised.
Okay, it's okay.
Oh,
It's okay.
okay, sir.
It's
Fine.
okay, sir. Okay. Okay then.
Yeah.
So these
Make
are
it.
final questions. So I because for any things you need to understand the background, then only you can go for the. This is the one of the cloud implementation. So it is very difficult to I don't know whether it is useful or not, but that all the topic is a huge one. But I want to hear because you are the faculty. At least if you understand the high level, definitely you can go your own and you can do the. That's why I just giving any viewpoint of the high level point of view. So all the public cloud, they not only public, hybrid cloud, every cloud, they used to give their own ecosystem of the DevOps. So they having their own tools. Either they leverage the open source tool, and or they basically build their own. But frankly speaking, I can tell you with my full consent, I have seen underline. You can just see the UI, but the backend, everybody using all the cloud vendor using the open source. Okay, nowadays all the backend done by the open source. No one, all these like a Microsoft, Google, they are smart enough. They are not investing anything from the understanding going for the new technology. They just buy the all the open source. They having every day. They basically they purchase a very small company. In US, so many small companies they used to build the so many tool. They integrate and they basically creating the features. Now yesterday you have seen those who are don't know they never seen the Azure or AWS console, I can say. So thousands of the services there, and all the services backed by the majority of the open source tools and technology, which is majority developed by the small companies, startups, not by the this company, big giant company. So all are the things. So coming to the Azure DevOps. In Azure DevOps world, they basically segregate the entire DevOps ecosystem in the five part. One is the Azure board, another is the Azure repo, another is the Azure pipeline, Azure is the test plan, Azure is the artifacts. So what is board? Board means is a dashboard like a Jira. I already shared with you. Like in a agile means we used to work in the sprint level, because we said that all our features like a backlog. Like a I backlog means you have a 10 chapter. That means I need to during the start of the sessions I need to complete all the 10 chapter. That means in your being a teacher, it is a backlog for you to complete the 10 chapter within a 6 month. So same thing in the Azure dashboard, all the sprint they say the backlog, and then one by one sprint we run. Sprint means small. This sprint can be happen in the 2 weeks or the 4 weeks. 1 week, 2 weeks, 4 weeks. Normally, in general, 2 week sprint is happening from the maybe Monday to Tuesday to Monday, or the what normally happen in this way. The sprint planning happen during that thing. All the team member they basically creating, giving the tasks. The Scrum Master giving the task, and after that they basically follow up the things. So this is called the Azure. So you can see this is the Azure board. In a board, what is the item story? We used to say that any requirement we used to say the user story. This is the user story, like a change the initial view, cancel the order form. This is the user story that need to be developed. Then new analysis. So this is, we can say, the backlog, the list of the requirement. We say that backlog. Then sprint means that backlog need to be defined, that which week we'll do the which tasks, and then what is the queue, the delivery and analytics. So this is the called the board. The next is the repo. Repo means it is a backed by the Git, the on the GitHub. If anybody see the GitHub, Azure repo is basically Git. So, I think do you know that GitHub basically purchased by Microsoft long back. So earlier, Microsoft having their own technology, Visual Source Safe, VSS. Then it is become a team. They said that is a team city or something like that. Then it is basically become a Azure repo. So now you have seen that is the repo means you can see there's a only Git, like all the ARM, then within the files, then introductions. These are the this means the repo means that, like this is a icon for the repo, this is the icon for the board. This is the board, this is the overview, like a dashboard, then board, then repo, then pipeline, then test plan, artifact, compliance, and that project, all that project. So now next is the Azure pipeline and Azure test. So this is the interesting thing, that architectural view, this is the all the pipeline that like a deploy these things, and all the pipeline environment, release, library, all are in the part of pipeline. Our test plan means I am basically having the test cases, that test cases need to be run, and those things. So this is the normal development team, like a developer used to, and the developer used to follow this part. I mean, operation guys follow this part. Developer follow the these need to, everybody need to follow the project management board. developer update the code, and then that operation guys deploy through pipeline, and then that testing team follow the test plans. So this is the, you can say, the management viewpoint of view. Now I'm actually give the CI/CD baseline architecture for the Azure pipeline point of view. I already shared the Azure pipeline, like from the Jenkins point of view. You can see the Jenkins, Nexus. I mean, one of the area which is basically service based. I mean, VM or the server level deployment, and another is a container level. So I'm giving you the reference architecture for the general service base, and another I will give for the AKS base, I mean Kubernetes base. Now you can see, like a developer develop the code, deploy the, I mean check in a Git repo, then like a Azure pipeline, they basically build, and after that build, it is moving to the Azure artifact. Then it is, Azure artifact means the Nexus thing. Then the Azure key vault is basically security point of view. That is, then it is going to the CI, means continuous integration. They will build, and after that they will deploy to the various target infrastructure, like a Azure App Service, virtual machine, Power Platform. Okay, maybe it's saying the same thing is from the staging. I mean, development environment or the UI staging means first we do the we used to have the multiple environment. First is the development, then it is a QA, then it's a staging, then it's a production. Suppose before production we used to go for the staging, and after that productions, then it is good. We operation guys see that everything is, all the VM is running properly, all that's application deployment properly, and that from that Azure having one features application inside. It is basically application performance. They basically looking like, suppose if I deploy one Java jar file, earlier it will basically 10,000 concurrent connections, but after the deployment, something new deploy, after the new releases come, it is become a not give that much of input. So all these things coming, all the metrics, based on the metrics that inside they basically give, and log from the, for any log point of view. So this is the overall architecture from the service based implementations. Same thing for the Kubernetes. I mean, from the Kubernetes case means is a Kubernetes, and same thing. We whatever I see the baseline, same thing is happened for the a case. Like happen the engineer repository, or here they say engineer repository. Same thing that pipeline will create it. Then the continuous integration happen. Then happen key. Then happen, we used to have a container registry. Container registry means Azure ACR. We say the ACR like a Docker hub. Like in general, we see the Docker hub. Microsoft having the ACR. So a pipeline we deploy in a non-production. Then again, whatever the after deployment, then is another thing is from the CI/CD means is a deployment we deploy in a case. A case means whatever the container, like a one container for the Nginx, another container for the Java, another component .NET, another for the Postgres, that will deploy in a case staging area, like a 1, 2, 3, 3, 4, 5, then 6, then 5, then it is running properly. We can say this is a they do the testing fine, then it will, that code need to be deployed in a production, and after that 6, then 7 in a deploy in the production environment, and then 8 it will get the application inside, like this one, this operation point of view. So this is the, you can say, the overall overall deployment point of view for the container level in Azure. So this is the CI/CD pipeline for the AKS level thing. So this is the things I basically I mean want to see. I mean share with you. So hope it will be understood. Maybe majority are the new things. Maybe if required that we can connect offline. So after that, if you have any question, Else I will basically go to the real Azure console then. So it will help, so that I just want to give some of the, I'm not going for the any CI/CD pipeline, I just explore the Azure part, Azure console, then you can understand what is the AKs and other things. So any question?
No, there is no hand raising.
No hand raise.
No. So you may carry on.
So I'm basically logging to my portal. This is my credential. So what happened? So see how many services are there. These are all services. You can see in them. So all are the Azure services. Just I'm giving for AI/ML, Azure AI Factory, AI Search. I maybe showing you the yesterday Synapse or the AI bot service, everything like computer visions. If you want that one computer, so that is you need to just start the service, give your input, and automatically it will run. So this kind of I mean, you can say the template is available. So the create computer visions, just click, and then automatically you require that all that, what is the project name, what is the region, all these things, then it's happen. So this is the from the analysis service, like a we have a nowadays the Azure, I'm working in the Azure database is a de facto things. I think everybody maybe I don't know how many people are know database is a hot cake. Earlier that is a Hadoop is a hot cake. Now is a database is a hot cake. Is basically uh, this it is a lakehouse architecture. Lakehouse means data lake, and the warehouse it is a single solution cater, and it is based on the Spark. So all the computing happening in the Spark and storage in a data lake. And they used to say so for the creation there is a concept called the delta lake. So this is happening. So you can see the log analytics, Prometheus. You can see this manage Prometheus. You have seen this is open source log analytics. So this is the Synapse. It's basically developed by them. It is based on the Azure. One of the service is a SQL having one service that Azure SQL Analytical Service, SSIS. So SSIS is a basically new name is a Synapse. So compute means like a whatever that, like a VM. Someone basically like if I want to create a one VM, I'm not going to create a VM, just giving the next one next. Suppose if I want to create a one VM, so create a VM, Azure VM. So I need to choose a one region, give the VM name VM1, ability zone leave it. So image, what I need a 1 to 2020. So x86 dev public key password, instead of the I give the username admin. What is it? Okay. So this is a firewall port. I only allow SSH. If I want is a web server, then I need to allow this. It will allow automatically. You understand? You no need to think about the firewall. All is there. Then next disks. What type of disks required? I need a premium SSD or something like that. Okay, 30 GB, 40 GB, 1 TB. So suppose I want a huge capacity of the server. So what I can do instead of that standard, so I can see, you can see that how many. So I need a CPU. Search by, like a, suppose I want to be E series. You understood? How many RAM? 8 core and blast. Wait. This is F series. Is a big one. So see 8 cores. Whatever required, I can select, and then it will be, then I need to check disks. If it is, I need a premium SSD, standard HDD is a slower one. What type of required? Then networking, I can create my own network or default network I can do. Okay, this is a new network. It will create from VM. Else management, and then you can see there's a management, monitoring, advanced things, tag, and then review create. It will create a one VM. These are sample for the creating on the VMs. Now, from the from container point of view, if I want to create a one Kubernetes cluster, so I need to choose a case. Where it is a case. See, this is Kubernetes service. Create a one cluster, Kubernetes cluster. So now you think this is only anybody can do, huh? Same resource group required, cluster details, dev test, something like that. Okay, how many there? So these things, you know. So node pool, how many node pool? This is only one node. How many node count? 2 to 5. 8 CPU. The networking, integrations, monitoring, advanced. I'm just giving you the just one the teaser so that next time. So for Azure DevOps point of view, like a you cite, Azure DevOps is a free version. You can go with the Azure DevOps. Sign in, you need to create a separate sign in for, I mean, same sign in you can do the dashboard. Yeah. Okay. Why it's here? There should be the ADO is should be the separate. Why? Just wait. Why it's coming to the, so you know the dashboard will come, but I don't know why it happened. Dashboard means what I am showing, this kind of dashboard. Dashboard will come this way. Azure DevOps. Azure DevOps service. Sorry, I mean the link is being changed. That's why I'm okay. Azure DevOps. Let me. After a long time, I'm basically using this one, so that's why my Azure DevOps organizations. Let's just wait. Maybe it's coming. Maybe. Think so. Yeah. Now you see, this is the one project. We can see that the board is there. Azure board, backlog, sprint. We can create the sprint here. New work item, first work item need to be created. So those things need to be created. This is the things. Then repository, we have a files. This is a repository for this project. This is a repository. Anybody can just commit, like it's all the Git related things. Pipeline means first you need to create the pipeline, then create the pipeline, then select the environment. Why is your code? Is it Azure or big bucket or GitHub, other Git subversions? Then you need to select, and then next you can do that. You can create a one pipeline. So all the releases will environments means you have a development environment, QA environment, production environment. You can define the environment like a 3 cluster. You have one cluster for development, one cluster for the QA, another cluster for the production. You can create the, so whenever you can create the development pipeline, you can create the configure such a way that it will go to the development. So this is the way happening. This is very interesting, but initially it will take much time to understand, but once you understand, it's very easy, frankly speaking. So all the click next. It's not like you need to write command configure. It's not like that. So that is from my side. So if anybody having any question, you can ask, or I'm done from my side. So any query?
Any query from the participants?
I'm stopping my.
No, probably there is no query. Few queries has been resolved during the session, so I think there is no more query. So okay, Urijit Mukherjee sir has joined. Niladrida.
Sorry.
Urijit Mukherjee sir has joined, and the
Okay.
next session will be started very soon.
Okay.
So, okay. So I will.
Okay then. Thank you. Okay.
Okay.
Bye. I'm leaving. Thanks for your time. Okay. Bye.
Arijit sir, we are taking a break of 5 minutes. We'll be starting the session at 5 o'clock sharp. Is it okay for you?
Sure. Yeah, it's okay. Fine.
Okay. Thank you so much.